可以，晚上好。Okay. Well, I notice now that the back 5 rows are now empty. So, except for some people back there. So we continue to shrink. Announcements. You should have gone to the first discussion section last week, and you should go to one this week. I've already put out problem set number 2. I haven't had the TA meeting yet to see where you are, if you finished problem set number 1, but you should be working on problem set number 2. And again, I emphasize there is not a flag that goes down. I say a word concerning chapter 6, and suddenly a flag goes down and you can try and do the problem. So you should be working on them, even if I haven't quite got there yet, but I will get there very soon. We're going to do chapter 5 tonight, or at least part of it. Also, I believe I got the counts for the discussion sections, and I believe Thursday afternoon is heavily overfilled. 40 students were in there. I will not allow discussion sections to go above a size of 25. So I encourage you to think about moving if possible. The night sections were actually thinner. Usually they're more populated, but this semester afternoons seem to be more popular. But anyway, if you can, am I correct, the Thursday afternoon section was very overfilled? How many students were there?
I don't know. It feels fine.
Well, that ain't fine. If it's above 25, I will not tolerate it. And please, if you can move and your section is too crowded, the TAs all have 2 sections, so you could try going to the other if you like the TA, or try another section. But I ask you to do this voluntarily if possible, and if that doesn't work, then I will become less friendly about it. But I will not have sections that are above 25. Okay? So please, if your section's overfilled, I will post something on the class website saying which sections are thinner. If you want to get more attention from the TA and you want to ask more questions, then you're better off, in a section that has fewer students. If you want to hide behind the other students, then of course you're better off in a big section. But you'll find that doesn't help your score very much. Okay, the other thing I have to make an announcement, and I make this announcement every semester, is that every semester people like in the back with the cameras and things like that come to this class either with surveys or with cameras or things like that. And as far as surveys or interviewing students, my rules are as follows. It is completely voluntary. You don't have to do anything you don't want to. Okay? You get no credit in this class for participating in anything that you're asked by people who hang outside the doors. Okay? Or in the rooms. I tolerate the people with the cameras. I don't like them being here, but I tolerate them as long as they don't cause disturbance. If they cause trouble, then I have to throw them out. But other than that, they're welcome to stay. Okay, and also anyone else who comes into class. Often we have people come off the street and sit in my class for some reason. I guess it's, better than, I don't know, playing video games? I don't know. But anyway, okay, so anyone is welcome as long as they don't cause trouble. But as far as interviews or surveys, the problem is, okay, again, last word about this. The thing is, in the past semester, I've said, okay, no problem, you want to do a survey, and then I had 5 more students show up with surveys, and the students are suddenly bombarded with surveys, because there aren't very many English-based classes in Tsinghua, and so it can get out of hand. So I've made these rules that, again, participation in anything is done, you get no credit in this class for it. If you want to help or interview, which are surveys, perfectly fine, as long as it doesn't interfere with the class. Okay, so that's all I want to say about that. So let me get back to the physics. So the last time we were in chapter 4, and we introduced Newton's 3 laws, okay? And we discussed them at some length. And then at the end, I had a little side section where I talked about chaos theory. And one of the 2 reasons I do that. One is that to, impart some wisdom from an old man who's seen this happen before about fields that rise and fall, and we talked about that. Another reason is that chaos theory is still F equals ma. It's still classical mechanics. It's not quantum mechanics. It's not general relativity. But yet it's not very well understood either. there's still very active research in nonlinear dynamics. So the idea that the only thing, the forefront of physics involves quantum mechanics or some string theory, that's not true. As you'll see, there's a lot in the classical mechanics that we don't quite fully understand. Okay? As I said, because we're very good at solving problems, if they're linear, become nonlinear, then our tricks don't always work and we run into trouble. And we'll see some more of that tonight. Okay, so I just wanted now to end the chapter 4, summing up the impact of Newton's laws and the introduction of the idea of force into physics. So the force suddenly into science. Before Newton, we didn't have a concept of force, really. Not in terms of an equation, F equals ma. It's almost impossible to overstate the importance of F equals ma. As I said, you have to feel the force, right? Okay. And we already saw Yoda explaining to the stupid guy here that force and energy are related, and we'll see more of that as we go on. So I asked the question, okay, we talked about Newton's law. So what is a law of physics? Well, the quality of law, how do you judge it? Well, I'll give you some list. Okay? First, the degree to which its predictions work. We like laws that agree with experiment. All right, obvious. Secondly, we like laws that are applicable in many instances. F equals ma is applied to many situations. That's when we consider it a very important law of physics if it has applicability over a wide range. Okay? We also like, very important again, this parsimony idea. We want this something as simple as possible. If we have two laws that explain the same phenomenon, we choose the one with the fewest moving parts. That doesn't necessarily mean those moving parts or those equations that govern it are easy to understand. Okay? So we have to be objective in this. And it's not the same thing as saying it's Shufuda. Quantum mechanics to many people is not Shufuda. But the number of laws that are needed to explain phenomenon is very few, which is why we'll study it. Okay? So this idea of parsimony we've talked about before. But this idea of aesthetically satisfying does have a place, as we'll see, in your bag of tools and tricks. Because a lot of what you do in physics, is going to be, what you're learning now is you're building up that gut feeling for when you know that you're doing something right. One of the things that I always find alarming is when students come to me and say, Bobby, when are you going to give us the answers to the homework problems? Well, first of all, I tell you, you're going to get the answers. You have the discussion sections where you talk about them. And basically, so you've got problem set 2 out now. And sometime around after I put out problem set 3, I'll put out the solutions to problem set 1. After I'm satisfied that you're through discussing it in your discussion sections. Okay? So then you'll get the answers. But one of the things to keep in mind is that many times students say, give me the answers, give me the answers. And you don't need them. I'm sure you've done problems for many years already, and you can develop a feeling whether you've done the problem right or wrong. You know that it's right. You don't need to see the answer. Oh, I feel so insecure, I have to see the answer. Well, 95% of the time you don't. Because you already know you got it right. Well, 5% of the time you're wrong, but that's a pretty small percentage. You should be developing a feeling when okay, I've done this problem, but I don't feel comfortable about that part. And that's the thing that you want to bring up in the discussion sections, or come to my office hours, or talk to me about. You identify which things you're insecure about, and focus on them. And that's what you're learning in here is, again, this idea of aesthetically satisfying Shufuda feeling, or gut instincts, is a very big part of science, and that's based on experience. And I can't teach it to you by doing examples on the board. That's something you need to do by doing the problems yourself. So no matter how great your teacher is, I had a great teacher. I was, a Jedi once before I got fat and old. And anyway, so the old days. And you could play the music, but we don't need to play that, right? Because it won't play anyway. Anyway, so here's another fun video. So you're smart Tsinghua students, but you're not scientists yet. Okay, anyway. So, okay, so take the main example from this chapter, F equals ma. This is probably the most useful formula you'll ever learn in science. As I said once, I had a class on classical mechanics, and the professor promised us, I'll give you every formula you need to do the exam. And he had F equals ma written at the top. And that's the only thing he gave us. I'll be nicer than that. Okay, so this is probably the most useful equation in